Good morning, everyone. Welcome to the course Geo-Python or Automating GIS Processes 1, depending on which version of the course you have enrolled to. You might have seen different names, but both courses happen here in the same place every Monday at this time. My name is Kamyar Hasanzadeh. I'm one of the lecturers of this course. I'm a lecturer in geoinformatics, so me and David teach the course together, but mostly for administrative matters. I'm mostly responsible for the geography side, so if you are enrolled to that version of the course, and David is coming from the geology side, so if you are a geology student, especially for administrative matters, David will be in charge. This is a bit unusual lecture because for a number of reasons. Well, it's the first lecture, so the structure of the lecture is a bit different. There's a bit more talking. And the other difference compared to the other lectures we will have in future is that, well, usually both of us are on site, so we teach together, but today David is on a work trip, so he couldn't be with us physically in this classroom, but he's joining us online. So before I continue and talk about the course, I would like to give the ground to David, who is joining us remotely, so he will introduce himself. David, you're online. Good morning. Students are seeing you. I couldn't get the camera working over the Zoom, but the students are hearing you and seeing you. Yeah.
Okay. Well, that's good. Good morning, everyone, and sorry that I'm not able to be there. This is one of my favorite courses to teach, and I would very much like to be there in person, but unfortunately, I can't complain too much. I'm beside the Mediterranean Sea in southern France right now for a work trip, so it's not the worst situation to be in. But from next week onward, as Kamyar noted, we'll both be there. And essentially, today is the first introduction to how the course operates and a bit about your first taste of Python, which should hopefully give you some idea of the way that things are going to go in the course. As Kamyar already noted, there's a lot of introductory stuff to go through today that we won't be doing in the future lectures, where we'll focus a bit more on actually programming and giving you hands-on experience. But for my part, I'm just looking forward to being there for the following weeks and hoping that you have a positive experience with learning to program in Python, learning new things, hopefully for those of you who already have some experience with programming. And just want to, say I'm happy that you've chosen to enroll in the course. And as Kamyar noted, for those who are enrolled with the geology course code, I think it's Geo 3030 or something like that. If you're enrolled in the course with that course code and you have any practical questions or issues, just feel free to let me know. Kamyar will talk about our communication using this Discord platform. So you can feel free to send me a message in Discord if you're having any issues with either getting enrolled or other things related to the course. But maybe that's good for now. And I think I will look forward to seeing you all next week in person.
Thanks for joining us today, David. So see you next week. Okay, so we are the lecturers for the course, and we will be with you the next 6-7 weeks or so. Before I get started, I would like to also introduce the course instructors. This year we have 4 course instructors who are helping us. They will be with you, especially when you're having your practical sessions on Thursdays and Fridays. And also they will be helping you out if you have questions over Discord and other channels we have for Discord. So if you can say a few words and introduce yourself.
Yeah, I'm Rosa. I'm a master's student in the Urban Studies and Design program.
I'm Nina. I'm also a master's program student with Design.
Yeah, hi, I'm Vili, and I'm a fourth-year student at the Bachelor's of Geography.
Hi, I'm Sandy, and I'm a master's student in the Geology program.
Yeah, thank you very much. Welcome to the course. They will be great help. So if you have questions, practical questions, The instructors will be there to help you. You're more than welcome to stay, but if you want to go do other things, you can also leave. So it's up to you. But yeah, about today's lecture. So we'll start the lecture today with a little bit of introduction. We usually don't have like a slide, so the structure of the course is so that we have like hands-on coding. So we start the course environment and then start like coding together, writing Python code. So that's the structure of the course. But today, of course, it's the first lecture. We will go through a bit of introduction and give you some practical information about how the course runs. So the title of the lecture today is a taste of Python. So we will already today start working with Python briefly, so you will get a taste of how this programming language works. So we will start by some introduction and going through some practical information of the course. And then we will learn about elements of computer and computer program as an introduction into world of programming, which might be new for many of you here. And then we will have an introduction to our course computing environment. You will see today and in the coming weeks that we have many things. There are many moving pieces in this course. We are using different environments. So at a first glance, it might look a bit confusing, but once you get started, once you start using them, you will see that they're not that confusing. So today I will show you briefly how things work in this course. And then in the second part, then we will have a short break in between. And then in the second part of the lecture today, we will start writing some Python code and get familiar with some of the basics of this programming language. So if at any point you have any question, feel free to interrupt me. But otherwise, we can start with practicality. Yeah, so I already introduced myself, and as we said, there are two versions of this code, so you might be enrolled to either of them, Geo-Python and automating GIS processes 1. So you already met the instructors for the course. So this is an open course. So of course, those who are officially enrolled to the course, they will be evaluated and they will get the credits and they will receive support from us. But all the materials of the course, for the sake of open science and education, are also published online. So now we are doing the first period course, Geo-Python, or the GIS 1. And that's the course website, so that's a very good resource. So you will need to refer to that website quite a lot. All the materials of the course are published there. One thing I forgot to mention is that we are actually recording the lecture, so we are being recorded right now. And the same day or the next day after each lecture, we will upload the video to the YouTube and publish it also to the website. Yeah, so if you miss a lecture, then you can check the website the day after the lecture usually and watch the video instead. Yeah, so these are the websites for the 3 courses. So the class meetings we have in this period, our lectures are on Monday, like now, from 9:15 to 12. And we usually take a break of 10 minutes, 15 minutes, somewhere in between, so you don't get too tired. Then we have optional work sessions on Thursdays and Fridays. Thursdays in the afternoon and Fridays in the morning. We don't check the attendance for the course. So of course you're encouraged to join the classes. It's nicer if you're all here. And since the course is practical and we will be doing things together, I think you will miss out if you're not here. But as I said, the lecture is also recorded. So if you happen to miss a lecture, you can still follow it online. But we do not stream lectures, so you cannot join remotely. The work sessions are also, well, they are optional, meaning that you don't have to be there. We don't check your attendance. But the idea is that the course instructors whom you just met will be available on site. So if you have problems completing your exercises, or if you have any questions related to practicality of the course or Python in general, the instructors will be always available during those hours there. So if you have problems, that's the best place to be to get your questions answered. Yeah, so on each of these practical sessions, there will be at least 1 or 2 instructors available to help you with your questions. The first couple of weeks, the exercises are easy. Already from this Thursday and Friday, these sessions will be held, but usually they become more popular over the course when the exercises start to get a bit more difficult. Yeah, and when you're registering, you might have enrolled to different work sessions. It doesn't matter which one you're enrolled to. You can just join whichever you want, so it doesn't matter. So you might be already a bit confused about what different versions of course and websites I showed. Here in this period, we are just doing the first course, the Automating GIS Process 1 or Geo-Python. And the idea is that we are introducing you to the world of programming with Python. So we do not expect any background in programming. If you have not used programming or Python language before, it's not a problem. We start from the scratch and we will learn together. So that's not a problem. Then there are continuations of this course, in case you're interested. For the students who are more on the geography side, the second part of this course, which will continue in the second period, is called Automating GIS Processes 2, and it will be my course. And there so actually we do not do any GIS in this first period, for those of you who are coming from geography, but we learn the basics which we will use later in the second period to do GIS analysis, spatial analysis. Similarly, for students who are coming from the geology side, this is an introductory course that will prepare you for a second course in the second period, lectured by David, which is a bit more advanced course, and in that course you will use your learnings from this first period. So in case you want to continue your learning, I encourage you to continue with those courses. So, yeah, before I continue with the materials for today, I would like to get to know you a bit. So this is a big class, so we cannot really, we want to have an interactive session, but since the class is big, it might be more efficient if we do polls. So we will use these polls quite often during this course. So if you can go to this address, actually I forgot to open it, but I will do it at the same time. So there are still answers coming from you, but so far I can see that we have more students to the Geo-Python version of the course, students coming from the geology side. But of course, not everyone is now present here. We know that we have more students also from geography, and also we have students coming from other universities, from Aalto University and University of Turku. And usually there are problems with enrollment at the beginning of this course, especially for students who are coming from other universities. So we have students coming from other places as well. Now I open the second question. How much programming experience do you have? So a lot of you have some or little experience with programming, and a few of you do not have any programming experience, which is okay. As I said, this is an introductory course, so that wouldn't be a problem. And it's expected there are not any super experienced programmers here, which makes sense because it's an introductory course. But hopefully there will be something new for all of us with different levels of programming experience. So now I would like to know which programming languages you have used before. A lot of you have some experience with Python already. Many of you have worked with R before, some with Java and JavaScript, and a few people who have experience with MATLAB, C, C++, and C#, and other languages. But many of you have not worked with any languages. As you know, in this course we are going to use Python, and Python is a good programming language, especially for scientific work and data science. So yeah. So now we can, if there are no questions, we can continue with the lecture. So as I said in this first part of the course, in this first course, we are doing, it's a very basic course, so we are introducing you, many of you don't have experience with programming, so we are introducing you to the world of programming, and particularly using Python language. So we'll start with very basics, and since this is the beginning of professional programming learning for many of us, we want to establish good habits. So one of the things we are emphasizing a lot in this course is good coding practices. So we will learn the basics of Python programming language, we will develop basic programming skills, and we will discuss essential good practices in programming. So it's not only about making the code work, we want to also write a code that is good. So if you start with good habits, hopefully when you continue using programming languages, you will use this, keep on these habits and develop them further. So let's now take a look at the course's website. So this is the address. You can just go to geo-python-site readthedocs.io. I will do the same here. So before I go through the structure of the course's website, I will give you a bit of motivation for the course. So one big change we have made to this course this year is that we have, this year, there is less stuff available on the course's website. So if you check out previous versions of the course website, you can see that there were more details. So what has changed this year is that David, with a few other people who have been part of this course over the years, have written a book, which is still kind of in development, but it has already a lot of good content. So the book is, there's also an online version of the book available. It's called Introduction to Python for Geographic Data Analysis. And we have put a link to the book. So there's a lot of good material related to what we do during this course here. So there is less material compared to previous years available on the course's own website, but there are a lot of links to the course, to this textbook. So you can read more about the material. So the book is written by Henrik Tenkanen from Aalto University, who was one of the founders of this course many years ago, together with David Wibb and Woko, who also used to work here in the Department of Geography. So this is the the textbook for this course, so you don't have to buy any book or get it from anywhere. If you just follow the link, everything is openly available. So starting with some motivation for the course. So if you're already sitting here and you have enrolled to this course, probably you know what to expect, you know what you need, and that's why you are here. But programming is a it might be scary for some people who have never used it. It might seem that it's like too much work, especially for many of us who are used to using software with nice interfaces. At the first glance, if you're not experienced enough, it might seem that, okay, I can avoid programming and just do things with software. I come from GIS background, so for those of you who have worked with GIS, you might be used to software such as ArcGIS or QGIS, and there are a few other examples. So you have a nice user interface, you can do many things. But if you do a bit more advanced stuff, you will see that there are limitations. If you really want to do a great job analyzing your data or create a very nice visualization, there is a limit to what is available readily in these software packages. So if you want to really take your data analysis and visualization to a next level, programming is useful. Another motivation for programming is automating tasks. This is something that we will get more into, especially in the next period. Very often the tasks you do are very repetitive. So in GIS, for example, you might be analyzing several layers of data similarly, and you might have dozens of those data layers. So if you want to do this manually, it might take days of work. But if you just write a script that does the analysis for one of the layers, and then you can just write a for loop, you can just repeat the process, you can just automate it. A task that would have taken you days and weeks of work, with a piece of code that you might write in half a day, depending on how complex it is, you might just get it done in a few hours. One of the main motivations for many students who enroll this course is the visualization side. As I said, many packages come with tools to visualize your data, but you probably know there are limitations. Sometimes you want something very customized, very specific, that the software you're using may not just do it for you. Depending on what background you come from, you use datasets like this. So they come in a format that are not very easily understandable. So if you just look at the numbers, it doesn't really speak to you. So that's why we often need to visualize our datasets using different methods. So if you visualize in this example, the numbers probably don't tell you much. You can just guess that, okay, you have some temperatures, you have other information, dates, for instance. But once you use a visualization, a proper visualization, then you start to see the message in your data. So this is something, not exactly this chart, but some visualizations such as these are things that we are going to learn how to make using Python during this course. So if you look at these are temperatures from January to December globally, and you can see that the trend is upwards. The temperatures have been increasing. But if you just look at pure numbers, you may not be able to see the trend, but with visualization, that's possible. This is another example. This is an example of a map that we will make for those who continue into to the second part of the course in automating GIS processes. So it's a map that shows you how the temperatures have changed in degrees Celsius around the world. Again, the numbers wouldn't tell you much, but once you look at the map, then you can see trends. And you can be even creative. One good thing about Python programming language is that it's very popular, so there are a lot of developers working and developing different kinds of libraries and modules. So for a lot of tasks you want to do, there is a good chance that someone has developed a library. For example, for a visualization such as this one. So using programming language, it's not only simple charts or simple maps you can create. You can even get creative and make visualizations such as this one, which is showing the temperature anomalies by country using a temperature data. This is another example of visualization that you can rather easily create using Python or even maybe other programming languages, which can help you explore certain aspects of your data set. Yeah, now that we are here, we have the course's website open. I can already give you a quick tour of the website, and then we can continue with the lecture materials. So that was the textbook. I'm going back to the Geo-Python's own website. So this is the home page of the website. There's a bit of information about how things work. In the general info, you will find the information about the lectures and where the lectures happen. So if you forget, you can always go back and check. And information about the instructors of the course and where you can find us and how you can contact us. I will go through the learning goals of the course during my using my slides, but here if you want to have a more detailed look at what we are learning every week, there's detailed objectives for each of the weeks. So like I said, in week 1 we are learning about computers, programs, and like basics of programming using Python, and there are detailed information about the contents of each week here. Because one thing we do, we publish the lessons one at a time. So every week before the lecture starts, like Monday morning, we release the material for the week. But in case you are curious to know what will be coming later, you can come to this page and check it out. There is information about grading. 60% of we have weekly exercises, so every week there will be something already starting from this week. This week's exercise is quite simple, but it gets more challenging over time. So 60%, we have 6 exercises altogether, 10% of your overall grade for each of the exercises. So 60% comes from weekly exercises, and we have 40% from a final project that you will be doing. So one thing, we will add more information about grading later, but one thing we do is that the grading is a bit different than many other courses. So if you get more than 95% of the grade, only then you will get a grade 5. So this scale is a bit different. Previous years it has been a bit confusing for students. Those who get over 90% expected to get a 5, but it's a bit different. And the reason is that a lot of the grade of the course comes from exercises, and exercises are not super challenging. So that's why we have put the bar a bit higher for this course. But we will publish more information about grading later on. One topical thing, something we started talking about already since last year, is the use of AI in this course. So many of us are already very well familiar with large language models and different AI tools such as ChatGPT, which is very popular nowadays. So you might be already wondering to what extent you can use ChatGPT in this course. You might have heard or seen that ChatGPT does a good job with writing text and also producing some code. As a general rule, of course we follow the instructions of the university. As a general rule, you're not allowed to use AI tools for doing your work in this course, but at the same time we are interested. We want to give you an exposure to these tools and how you can use them properly in your work. So you will have the chance of using AI in some of the exercises. So in exercises where it's alright to use AI models, we put somewhere in the material we write AI LLM okay, which means that you can use it, and there are instructions on what extent you can use. So the rule is that you cannot use it to solve your exercises, and in cases where it's allowed to use, you do it transparently. So you use it and you tell us to what extent you have used, what prompt, for example, you have used. And in one of our lectures, I guess on the 3rd week, we will walk you through how we can use AI effectively for programming. So we will walk you through how you can do it. So that was one important piece of information. But licensing, as I said, this is an open course, so information can be used in other places as well. And there's more information about people who have contributed to this course over the years. So one of the good things about this course, we like this course a lot, as David already said, and many students like this course. And one thing that makes this course a bit special is that none of us here are programmers. So we all come from different backgrounds. Like David is a geologist, seismologist. I come from GIS background. So none of us are programmers, and so we are all on the same page. But we need programming as scientists, as people who work with different kinds of scientific data. So there's no need to be scared of programming if you don't have any experience in it, and we are here to learn together. And I guess all of you already know what is a program, and we will go through the details of what we mean by software and programming later on. But one thing is that we aim high, we want to become as good as possible in programming, but since we are not specialized, most of us are not specializing in software engineering, you don't have to become a superstar. Of course, the better, the more comfortable you become with programming, it's easier for your work, but the aim here is to have a functioning, a working level of understanding of programming so you can use it for your own field of research, field of work. So why do we want to learn to program? Geology and geography are becoming increasingly quantitative, as many of you already know through your courses and your experiences. And basic programming skills are one of the fundamental skills that will help you become a better scientist. So there is a lot of quantitative data, and there's a limit how much you can do using software. If you know programming, you can become a bit better at doing things. As I said already, programming can very often replace the software. So in this course, we are not using any software. You're just using pure Python without installing anything other than Python on your computers. So it can fully almost replace programming, but very often you don't want to do that. For example, for those of us, again, coming from a GIS background, you want to still have QGIS, for example, where you can visualize things and see them. But using programming, you can complement the software very nicely. So you know that, for example, in ArcGIS, there's a Python window where you can add functionalities to your to your GIS environment. Same thing exists in different software, like in QGIS, in Paraview, or Google Earth. You can still use the software, but by adding a couple of codes somewhere, you can extend the functionality of the software. So even if it doesn't replace the software for you, it can still make the software even better for you. This is an example from QGIS for those of you who have done GIS before. So you can still enjoy the user interface of the QGIS environment. At the same time, you can open a Python console and just do something with the code. For different reasons, simply because the analysis is not readily available in the software, or you want to just write a for loop, something that we will learn during this course, to automate or repeat the process. So it's also a good addition to your software skills. And programming can actually be fun. Once the learning curve at the beginning might seem a bit, less fun at first, but once you start solving problems, once you actually produce something and that code is like making your life easier, producing results and visualizations, then it actually becomes more fun. The one nice thing about programming is that if you have a complex program, you can break it down into simpler pieces. So very often when we write code, if you have a big project, if it is your master's thesis, for instance, you can break your problem into smaller pieces of code, and then the pieces of code will work together to solve your problem. Writing a code also helps you with developing a solution for whatever problem you're solving. Because when you are using a software, you have this magic toolbox, you input your data, you run it, you get the output. But when you're writing the code yourself, you're thinking about the process. You just you're involved in the process, and that helps you with problem solving. So if you have a big problem you're solving, this helps you with finding a strategy for solving it. And then you can always test your solution. You know what you have done. For example, if you have done some analysis in ArcGIS and QGIS, of course, you can always read the documentation of how the calculation is done. But when it's your own code, it's super transparent. You know what you have done. You can change things. You can improve things. So all of this can be, in turn, exciting and rewarding. Of course, when the code works. You will see those red messages. You will get errors from time to time. And that can be a bit frustrating. But when you get it working, it is very rewarding. So we are familiar with the scientific method. So we start by asking questions. We gather information, resources, data to answer that question, and we usually have some kind of hypothesis, and then we perform analysis, we perform tests to see whether that hypothesis is valid or not. We analyze the data, and once we do the analysis, we interpret the data, the results from our analysis, and see whether that hypothesis that we started our work with is valid or not. And then you usually publish your result. This could be your master's thesis, it can be like some exercise for a course, or it can be a scientific article. And then very often you get back to your work and test it. You might do it for another data set. So you might be wondering how the programming can contribute to this scientific process. Well, it can help you with gathering information and resources. So very often you might want to get your data from somewhere, and that somewhere has an API. So using programming languages, you can fetch the data from many sources. This is something we will address more in the second part of this course. We will learn how to get data from different sources. You can perform different, once you collect the data, you can do different kinds of analysis, perform different kinds of tests, and explore your data. And this is something that we will already start doing during this period and continue in the upcoming courses. And then interpretation that you can do using your results, using the visualizations you create. And one good thing about using programming is the possibility of testing and redoing things. So very often when you use software, you do something, you might not even feel like going back and remembering what you have done. But the code is just in front of you. You can just look at it, test it, rerun it. So that makes testing and reproduction of your work easier. So now let's go back to the poll. You probably have it already open. So we want to see what is a program. Add your thoughts on what a computer is. And if the option is already there, written by someone, instead of writing your own, if you don't have anything to add, you can just vote one of the available ones. Okay, a lot of good answers are coming from you. So the most popular option here is that a computer is essentially a processor, which is true. Okay, or it's a processor that has also possible display input, so you can input data probably, and there's an output. It can be in form of a monitor, but yeah, usually there is some kind of input and output. Some of you think it's more of a computing machine or a machine for automating tasks. More simply put, it can be seen as a calculator that accesses different software. If you want to be more detailed with the hardware that exists in a computer, yeah, it comes down to parts that make a computer a computer. You have a CPU, GPU usually, motherboard, all the parts depending on what kind of computer you have. There's of course memory and storage, that is true. It's a binary processing system, that is also true. The logic of computers is binary. Yeah, so it's not exactly a program, but it works closely with programs, and we will see now how that is. So let's get back to our slides. Very good answers from you already. So this is an example of a computer in very simple words, how it works, and most of it came already through your answers. So it is a package of hardware and software. So input devices, so there's an input, it can be a keyboard, it can be a mouse, or any other thing that you can use to provide data. If it is coming from internet access can be considered as an input here. Then you have processing happening, you have CPU, GPU, whatever you have in the hardware package, and some main memory that your computer works with. And then you have an output device. It can be a display that shows you the result of your work, the result of the process that has happened on the inputs you have put, or it can be a secondary memory. So if you have a hard disk, data, the computation is done, the results are written to the storage. It may not be necessarily shown on the output device. Yeah, so a computer is a machine that stores and manipulates information under the control of a changeable program. So in your answers, you said that a computer controls a program. It's kind of true, but it's like a two-way relationship. So it's mostly a program controlling the hardware. So it's the commander of what a computer does. So if you turn on your computer and you have an operating system, Windows, Linux, whatever you're used to, but that operating system, which is a very big piece of software, is controlling how your hardware works. There's a mutual relationship. Of course, the hardware is running the code, running the program, but the program also controls many behaviors done by the hardware. So it's a mutual relationship. And very often the input information is a bit raw, so similar to the data we saw a bit earlier today, but after the calculation, the computer can be used to make the data a bit more useful for you and show it in a way that we can understand. So it can be a data is essentially in binary format as input to the computer, but the output you get is hopefully more understandable. So computers are great. They have made our life easy. We can do so many things compared to 100 years ago, thanks to the computers we have access to. But there are things that computers are not good at. But let's just start with the things that the computer is good at. So computers are good at well-defined, clear tasks. For example, if you're using programming, you have to be very accurate. So if you ask the computer what is 2 plus 2, it can answer you perfectly, because it's a very clear task. If you have a bit of vagueness, that doesn't work so well. But of course, now there are modern technologies of how to handle this using AI, machine learning, and so on. But in the very core of the computers, you have to be very clear. Then it can do the calculation perfectly for you. Computers are very good at storing data. So it used to be a problem. For those of you who are coming from a GIS background or geography background, Especially, you know that maps are now more of an output of your work. So you have data coming from somewhere, you visualize, you have the map. But maps used to be 1,000 years ago, 100 years ago. They used to be where you stored the geographical data. You didn't have a computer, so the map you created was essentially a storage device. But now computers can store large amounts of data. So it's perfect for storing large amounts of data, and you can use the computer to manipulate your data. Many of you said that it's a good calculator. It is a calculator, and one good thing is that it can be doing things like repetitively, which is very nice. And if you provide good instructions, this is what we do using programming, it can process the data for you effectively. So these are something that we are going to continue with in the second part of the lecture today. But you can see a Python prompt here. We are using print function, which is a very basic core Python function to print the output of 2 plus 2. And that's what you get, returned value. But we are going to work with this a bit later today. So computers are not good at things that are vague. So if you have a very abstract or poorly defined task, computer would struggle with coming up with an answer. So one example of this, for those of you who have used AI models before, you see if your prompt, well, it's essentially a computer that is handling your prompt. If your prompt is vague, and this is something we are going to get back to on the third lecture, you will see the output may not necessarily make sense. But if you tell exactly with a lot of context and detail, very clearly what you want from the computer, then you can get a better response. So, for example, if you want to get the output of pi value, the exact value, it can have many decimals. There is no end to the number of decimals. So it's a bit vague for computer, but you can more clearly tell the computer that I want the pi value up to 1,000 decimals. Then it's a clear task for computer and it can easily do it for you. Something that is very difficult, if even possible, manually. So computers are good at storing large amounts of data, but also doing computations very effectively. So the computers that we have access to right now are already super powerful compared to before, but also nowadays we have supercomputers, even quantum computers, which are very powerful in doing tasks that are a bit heavy and more consuming. So what you're essentially, so as I said, computer needs clear instructions. So how do we provide that instruction to the computer? We do it using programming. So we have the data which is read to the computer in whatever format, essentially as a binary input, and then you provide very clear instructions what you want to do with the data, and then the computer just follows your instructions. So this is an ancient Fortran punch card that was used before our modern computers. So what it did essentially is to provide an instruction for the computer how to process the data. So a program can be seen as a detailed list of step-by-step instructions telling the computer exactly what to do. So you cannot assume computer knows what you want to do. You give the instructions in full details, then the program can be changed to alter what the computer will do when the code is executed. So that's the nice thing about programming. You can change the code, then the output is different. Change the instructions. So program and software are essentially the same thing. You can use either of the terms. So what we are doing in this course, we are developing software essentially, just starting with simple things and then it gets more complex over time. So what is a programming language? So the language that computer understands is that binary ununderstandable thing that we already saw. So you don't want to talk in that language to the computer. That was the beginning of the computers. Nowadays we have these modern programming languages that are some kind of intermediate between you and the computer. So it's some kind of language that you can use for giving instructions to the computer, or in other words, talk to a computer. So computers do not yet, we don't know how it will be in 100 years or more or less, how they will be. But right now, they do not understand your language. Of course, there are these examples of chatbots or AIs nowadays, large language models, but it's still, there are instructions behind those. It's not that you're directly talking to the computer. There is a software between you and the computer. So a programming language is like a code of instruction for the computer to follow. It is exact and unambiguous. Like I said, you cannot be vague with computer. So in programming language, when you write something, it's so clear for the computer. Computer knows what it has to do. If there's any problem, then you get an error. Every structure has a precise form, syntax, and a precise meaning, semantics. So each programming language has a way of writing. So if you want to print the outputs in Python, you just write print, then you have 2 brackets, and whatever you want to print is between those brackets. So in different programming languages, you have similar function. It might be called a bit differently. The syntax might be a bit differently. Instead of bracket, you might have something else. So that's what syntax is. So if you're familiar with programming, now you learn about Python, then you are familiar with the logic of programming, how it works, but you're only familiar with the syntax of Python. Usually learning a second language is easier because you know the logic of programming, how it works. You just need to know how to write it. So very often, when we want to automate a task, and this is something you're going to see in a few weeks, in Python, you write a for loop, and for writing a for loop, you write for, then there's a statement, then there are these columns, then write something. So that's the syntax in Python. The same concept exists in Java as well. You just write it differently. And there are many programming languages. Python is just one of them. So what does developing a program involve? Well, as a first step, you should come up with a specific list of instructions for the computer. So you should first plan. You want to solve a problem. Again, my examples are mostly from GIS world. So if you want to create a map of world, for example, that map of temperature anomalies we saw around the world. So we should think, okay, I have this raw data of coordinates and temperatures and different dates. So how should I process my data? So then you come up with a list of things you want to do. So you want to say, okay, this data is in raw format, the dates are weirdly written, I will convert it to a format that is more understandable for me and the computer. So you process the dates, then you might change the format of your data, then you produce a shapefile, you produce a Geo-Python, things that we are going to get back to later on. Then you produce the visualization. So you come up with a list of things you have to do. So the following list will serve as a general software development strategy. So depending on your problem, the problem you're solving, this can be different. But generally, you start by analyzing the problem. You need to know the specifications. So you should know how you want to analyze the data. And then what are the specifications? What data formats you're using? What programming language you're using. And one concept that we will get back to briefly today, and we'll use a lot later on, is the concept of libraries in Python. So there are readily written codes in repositories. Depending on the task you want to do, you should know, okay, what libraries do I need for my work? But we will get back to that later. So what are the specifications? And then you come up with a design. You implement that design, you write the code, and then you have to, of course, always test and debug your program. It rarely happens that you just write a piece of code and it immediately works. Very often there are problems, especially if it's a bit more complex, longer program. And then, of course, you have to maintain the program. And what do we mean by maintaining? Sometimes it's just you're making the software for a customer, for public, and the needs change. So if you think of like how Microsoft Word has evolved over the last 2 decades, it has evolved to respond to the needs. So if you are maintaining our software, you just make updates every now and then. There are also updates you need to make the software work. So every now and then there is a new version of Python released, there are new versions of the libraries you have used released, and it might cause the program crash. So if you have written a code 10 years ago using Python version, I don't know, 1 point something or 2, now if you run the code, Python has changed a bit, so you need to make a bit of updates to make it work. So maintaining the program is important if you want to keep it in working condition. So, as you can guess, this slide is from David. He has been living in Finland for quite some time, but he still struggles with temperatures. So he's so used to Fahrenheit, which is commonly used in the US, and then if it is especially winter and he wants to go out and it is like -10, for him it's like hard to understand immediately, okay, how cold is that? Do I need to wear my thick jacket or not? So if this is a problem you want to solve, well, this is a very simple problem. But thinking of it from a programmatic point of view, well, what is the problem? I want to convert temperature from Celsius, which is difficult for me, into a unit that is understandable for me. So that's the problem. You need to write a formula, a conversion to do that task. So the formula for converting Fahrenheit to Celsius is easy. You can just Google, find it, that's not a problem. But then you want to write a program that does it for you. And you're living here in Finland, so you need to check the temperature every day before you go out. So if the software is written, then you can use it every day and maintain it. So it does this task repeatedly every day for you. So this is an example of a simple program. So how do you approach this? So you first analyze the problem. So we know what our problem is. We want to convert the temperature. And then you determine the specifications. So you think, okay, I want to write this in Python. I need this function, this and that for doing this. And this is the formula for doing the conversion. Then you write the code. Very often it's a good practice, especially if you're doing a bigger program, like what you will do in your final project this period, is to write a pseudocode. So it's not the code exactly in the syntax. So it doesn't matter how you should exactly write the code in Python, but like just a sketch of the logic of your program, pseudocode. So that's often a very good step if you're starting to write a more complex program. And then once you have the pseudocode, then you're familiar with Python, you know how the syntax works, you write it in the exact syntax that will produce the output for you. And as I said, then there is testing and debugging of your program and maintaining. So in case of David, he has been living in Finland for a while. So if he wants his code to be working for a longer period of time, then he probably has to keep it up to date to make it work. So as a recap, you know what a computer is. Essentially, as you said, it's a big piece of processor. It's a big computer that has many components. And it has this two-way relationship with the software, so it kind of doesn't control the software because those are the instructions. You cannot, unless you are instructed to, you cannot change the instructions. But it has a two-way relationship anyway with the software. And the program is essentially the instructions to the hardware, how to perform different tasks. And we learned also about different steps we need to take in order to produce a program. So this was more on an abstract level, but now we take a short break, and when we come back, we will see how this works in practice. So let's take a 10-minute break and come back here, continue coding.